All right, this is problem number 8, Math Counts chapter competition. It's a team round problem. And I'll tell you right now, this explanation will take longer than actually doing the problem. It's definitely something you can do in about five to 7 minutes, but the explanation, as most explanations are, it'll just take longer. All right, so here we go. Here's what I see. We have an isosceles right triangle, ABC, and we know that AC and A and BC are both 10 units. And so we know that each thing is one spaced one apart, but that doesn't matter. We just want to know how many isosceles triangles there are. And so initially I do see a big isosceles triangle, but I see a bunch of small, like really, really small isosceles triangles too. Now, it is a little hard to start thinking that, you know what, there are larger isosceles triangles, just not the big isosceles triangle either. And we have to count those as well. So what we really need to do is we need to find a way to find a pattern instead of trying to count the triangles, because counting the triangles can take a really long time. So I'm going to break the triangles into two different parts. We have triangles that are facing down and to the left and triangles facing up and to the right. And so I'm going to start with these downward facing triangles because they're the most obvious looking triangles, right? And so if I look here, we have 1, and then on this row we have 2, this row we have 3, 4, 5, 6, 7, 8, 9, 10. So for triangles facing this direction that have a side length of 1 triangle, we're just going to add the numbers 1 through 10. And when I add the numbers 1 through 10 together, I get 55. Okay, well then I can have triangles that are 2 by 2 as well, right? 2 by 2. And so for these triangles, well, let's see how this works. So I have 1, but then I can slide it down 1, get 2, 3, 4, 5, 6, 7, 8, 9. Okay, so this time I only get 9 instead of 10. And then on the next row, if I move it to the right one, I get 1, 2, 3, 4, 5, 6, 7, 8. And that's just going to continue. I'm going to be adding the numbers 1 through 9 together, right? Because 9 was the most that I had in one place. So when I add the numbers 1 through 9 together, I will get 45. Well, I think I see a pattern here, but we want to make sure that it is the pattern that we think it is. So I'm going to do one more. So if I have a 3 by 3 triangle, well, that's 1. I think I'm going to get 8 in this one. 2, 3, 4, 5, 6, 7, 8. And then here I count, I can get 7, right? So at this point, if I add the numbers 1 through 8 together, I will get a grand total of 36. So, and that pattern is going to continue. So this was a 3 by 3 triangle. So if I continue that pattern, I'm going to get 55 starting from the top, 45, 36, and then the next one, if I add the numbers 1 through 7, I'm going to get 28. Add the numbers 1 through 6, I'm going to get 21. 1 through 5, I'll get 15. 1 through 4, I'll get 10. 1 through 3, I'll get 6. So if I add 1 and 2 together, I'll get 3. But if I add, well, it's just 1. The last one's just 1. All right, so now I know how many triangles I have that are facing down and to the left. Now let's look at the triangles that are facing up and to the right. And hopefully we can find another pattern that helps us. All right, so in this case, same basic idea. I'm going to start with this one right here. So how many do I have on this row? Well, I have this 1, 2, 3, 4, 5, 6, 7, 8, 9. This row I have one less, which is 8. 7, okay. And those are really easy to see. So now we're adding numbers 1 through 9 together. And already I know 1 plus 2 plus 3 all the way to 9 is 45. Now what happens if I have triangles that are 2 side lengths long each? Well, this one right here is 1, but notice how I've really had to start 2 segments inside already, right? So this is going to set up a slightly different pattern. So we have 1 on the bottom row, 2, 3, 4, 5, 6, 7. Oh, so that's a little different than the other orientated triangles. Now we're only counting the numbers 1 through 7, and that would be 36. So let's see if that pattern of skipping one of the numbers in here happens again. So let's go with the 3 by 3. And this time, notice how we've had to start even farther inside the triangle to get my 3 by 3. And I'm only counting the triangles facing this direction. So we have 1, 2, 3, 4, 5. Oh, so here we have the numbers 1 through 5, which would give us 21. So I've skipped the 55, and I skipped the oh geez, the numbers 1 through 7 don't add up to 36. That's the numbers 1 through 8. 1 through 7 add up to 28. The numbers 1 through 5 don't add up to 15. That's the numbers 1 through 6. The numbers 1 through 5 add up to 15. Oh my goodness. So notice how we skipped this one here, then we skipped this one here, and then we skipped this one here. So following that pattern, we're going to skip, skip. All right, and that makes sense because the largest triangle that we're able to get here is going to be this 5 by 5 triangle right here. That's in the absolute middle of it. I can't move this triangle up or down anywhere, right? Without it going off of the page or off of the triangle. See, that one vertex right here is off. If I go this direction, this vertex over here is off. And so I know there's only one 5 by 5. So let's make that pattern here. So we have a 45, then we have the 28, then we have the 15, then we have a 6, and then we have 1. All right, so now this is a calculator section, thank goodness. And so what I'm going to do is I'm simply going to add those numbers together. And if I add them together, I should get 315, I hope. So 55 plus 45 plus 36 plus 28 plus 21 plus 15 plus 10 plus 6 plus 3 plus 1. Now another column plus 45 plus 28 plus 15 plus 6 plus 1. And there we go, 315. And there's our final answer.